Hello. I've been away from YouTube for a couple of months, so to those of you still subscribed and still watching, thanks for sticking around. And it's beginning to rain, so I'm going to set the weather to clear. Okay, in this video we're going to be talking about a strange fact about cubes and squares. And this is going to seem like a seemingly irrelevant fact, and I'm going to try to make the point that actually it's the small irrelevant facts in mathematics that make up the bigger, larger, more flashy proofs and theorems that you might know about, the more famous ones. So we're going to start by looking at this cube. This is a block with a side of 7, so this is 7 cubed, and it's filled in, so there are 7 cubed blocks in here. It's totally filled in, guys. Okay, if it was filled in, there'd be 7 cubed blocks. How many is that? That's 343 blocks in this cube. Oh, ignore that stuff over there. That's just that was just me messing around. Okay, so 343 blocks, which also can be arranged into 3 other squares and a larger square. So these 3 squares here have a side length of 9. So these are 9 squared. So each square would have 81 blocks. And then this square here has a side length of 10. So that's 100 blocks in that square. So it's maybe surprising looking at it. It looks like these squares would have more blocks than this cube, but actually they have exactly the same number of blocks. So you can think of it as taking the blocks from this 7 cubed and arranging them into 3 squares and another slightly larger square. Okay, so it turns out, this is the fact, that if you can arrange a cube, the blocks from a cube, and by the way, I'm talking about cubes with an odd side length. So 7 is an odd number. So this works for any cube with an odd side length. If you can take the blocks from the cube and arrange them in this way into 3 squares and another square, then it turns out that means you can also do the same thing for the side length of the cube. Okay, so this was 343 blocks. This is 343 blocks. Then we're going to do the same thing with this side length of the cube, which is 7. So we can make this same arrangement out of 7 blocks. Can you think of how to arrange 7 into 3 squares plus another square? So what would those 3 squares be and the other square? Well, we could do 2 squared. Let's try that. 2 squared and 2 squared. Oh, you can already see it's not going to work, right? We're already at 8. We only need to make 7. So what's another square we could use? Needs to probably be smaller than 2. What's the only other square smaller than 2? That's 1. So we're going to create 3 squares of 1. And okay, it's a little bit confusing doing this in 3D because I'm technically made 3 cubes, but we're kind of thinking 2D from above. So that's 3 squares of 1. And then we've got another square with a side length of 2. Let's do it in blue. Okay, so again, we've made that arrangement of 3 squares plus another square. So 3 plus 4 is 7. That's the side length of the cube. And the volume of the cube can also be arranged in that way. 3 squares plus another square. Pretty strange little fact, right? Seems like, why the heck would you ever want to know this? Actually, I used this fact in a recent video I made talking about if you can create a cube out of the blocks of 2 smaller cubes. And I've talked about this fact in another video before. Actually, I was using these patterns over here. Okay, so can you create a larger cube out of two smaller cubes. And it turns out it's impossible, and you need to use this fact, that if you have a cube with an odd side length and you can arrange it in this way. Oh, it's raining again. Let's set the weather. And you can arrange it in this way, then that means you can arrange the side length of the cube in the same way, and it turns out this seemingly unrelated fact helps you prove that no, in fact, you cannot create a large cube out of two smaller cubes. Now, the proof of this fact, that this is always the case for any odd cube, you can always do this. Sorry, you cannot always arrange an odd cube in this way, but if you can, then you can arrange the side length in the same way. Hope that makes sense. But the proof of that fact is quite long and complicated. And I guess the point I wanted to make with this video is that we study a lot of seemingly irrelevant things in mathematics. It's a very common question to ask, why would I ever need to know this? And it turns out that the things that mathematicians study, they might not always understand or know why they would be important. Like the person who proved this fact probably wasn't thinking, oh, this is really important. And even the proof I'm talking about, that you cannot add two cubes to make another cube, that's not a particularly interesting or important fact either. But there are cases where mathematical theorems are really important, and they're often built on these small little nuggets of information that someone's found out once, that no one at the time understood why that would be useful, but it turns out to be a really important building block in a larger proof or theorem. And so as we watch the sun go down and the stars come out, hopefully you've got something out of this video, and I'll see you in the next one. Bye for now.